Last summer, my whole building lost power for almost 2 days in the middle of a heat wave. By the second day, everything in my fridge had gone warm. I was throwing out spoiled food and drinking lukewarm water. And I caught myself thinking, what on earth did people do before electricity? How did anyone keep food cold in the heat, let alone make ice? That question sent me down a rabbit hole, and it ended somewhere I did not expect. Around 400 BC in the Persian desert, one of the hottest, driest places on the planet, people were making ice. In summer, with no electricity, no machines, nothing but mud, water, and a clever understanding of physics, they built giant cones of mud brick called yakshals, literally ice pits, and pulled solid ice out of the desert when it was 40 degrees in the shade. Your freezer does the exact same job today. It makes ice on demand. The Persians just did it 2,400 years earlier by hand. So in this video, why making cold is secretly hard, how the Yakhchal froze water in a desert, the genius trick that did the impossible, and how that same idea is coming back. Let us make some ice. Here is something we never think about because a fridge hums away in every kitchen. Making cold is hard. Making heat is easy. Rub your hands, strike a match, light a fire. Humans have had fire for hundreds of thousands of years, but cold, you cannot make cold. There is no such thing as a coldness you can pour into a box. Cold is just the absence of heat. So to make something cold, you have to take heat out of it and move that heat somewhere else. And heat does not want to go that way. Left alone, heat always flows from hot to cold, never the reverse. So for almost all of history, cold was a luxury you could only harvest, not manufacture. If you were rich, you sent people up into the mountains in winter to cut blocks of ice and snow, packed them in straw and hauled them down, and most of it melted before it arrived. Ice in summer was something emperors bragged about. Now picture the Persian plateau. Blazing days, almost no rain, no glacier next door. By every common sense rule, that is the last place on earth you should be able to keep ice. And yet that is exactly where someone cracked it. So how do you freeze water in a desert? It starts with the building. A yakhla is a huge dome of mud brick, sometimes 18 meters tall, sitting over a deep pit dug into the ground. The walls at the base are enormously thick, up to 2 meters, built with a special Persian mortar called saruch, a mix of sand, clay, egg white, lime, goat hair, and ash that is almost waterproof and an incredible insulator. That thick dome does one job brilliantly. It keeps heat out. Inside it is shaded and still, and the deep underground pit stays cool year-round, the way a cellar does. Next, water. A qanat, an underground channel, itself an ancient marvel, carries cold water for kilometers from the mountains without ever seeing the sun, so it arrives cool. And around the structure, high shading walls block the sun from the water, while tall wind catchers, the badgers, funnel any breeze down across it so it evaporates. And evaporation, it turns out, is cold. Every drop that evaporates carries heat away with it, chilling whatever is left behind. The same reason sweat cools you down. But shade and evaporation alone get you cool water, not ice. To actually freeze it, the Persians used one more trick, and it is beautiful. Quick one, if a desert ice maker with no electricity is blowing your mind a little, that is exactly what this channel is about. Subscribe, and the next everyday thing in your home gets the same treatment. Okay, the trick. On a clear night, the Persians filled long, shallow pools beside the Yakhchal with a thin layer of water. And overnight, that water would freeze, even when the air never actually dropped to freezing. How? Because the night sky is cold, not the air, the sky itself. Outer space is about minus 270 degrees, and on a clear, dry desert night with no clouds in the way, a pool of water can radiate its heat straight up into that emptiness. It literally beams its warmth out to space as invisible infrared light, faster than the air can warm it back. So the water loses enough heat to drop below freezing and turn to ice on a night that only felt cool. This is called radiative cooling, and the Persians were using it 2,000 years before anyone wrote down the physics. Then, before sunrise, before the sun could undo it, workers collected the fresh ice and rushed it into the insulated pit of the Yakhchal, layer after layer, to be stored all through the brutal summer. And this was not one freak building. Yakhchals dotted the Persian world, and the idea spread across the dry belt. Variations appear in Afghanistan, across the Middle East, into parts of India. For centuries, ordinary towns had a public ice house, cold drinks, chilled food, and a frozen dessert called falude, which Iranians still eat today, all came out of these mud cones. Think about what that means. A working cold chain, ice stored for months, running on nothing but shade, evaporation, and the night sky. No fuel, no moving parts. Then the modern world arrived. In the late 1800s and the 1900s, mechanical refrigeration appeared. A pump, a special gas, a compressor that could force heat to flow the wrong way using electricity. It was smaller, it ran any time of day, in any weather, and it did not need a clear night or a desert climate. So the great mud ice makers fell out of use. Many still stand in Iran, hollow and quiet, like the ruins of the world's first freezers. The technology that kept a civilization cool, replaced and half forgotten in barely a generation. Now open your freezer and look at the ice. The machine that made it works differently from a Yakhchal. A fridge uses a compressor and a refrigerant to pump heat out of the cold box and dump it into your kitchen. That is why the back of your fridge is warm. Different mechanism, but the goal is identical. Take heat out of here, move it somewhere else, and keep it out with insulation. Your fridge's thick foam walls are doing exactly what 2 meters of Sarouge mud did. And the Yakhchal's actual methods are not gone, they are coming back. Evaporative coolers, the swamp coolers, cool millions of homes in dry climates today with nothing but water and a fan. Pure Yakhchal, and the headline trick, radiating heat to the night sky, is now one of the hottest areas in materials science. Engineers have built paints and films that beam heat into space and stay cool in direct sunlight with zero electricity. Passive radiative cooling presented as a breakthrough a Persian ice maker was using at scale 2,400 years ago. Here is what I love about the Yakhchal. We think of cold as something a machine makes, a thing that needs power and a motor and a plug. But the Persians understood something deeper. Cold is not a substance, it is the absence of heat. And if you are clever, you do not have to power anything, you just have to give the heat somewhere to go. They gave it to evaporation, they gave it to the cold night sky, and they pulled ice out of a desert. The buildings are mostly empty now, the Connaught's drying up, and most people walking past them have no idea those mud cones were once the local freezer. But the idea did not die. It is humming in your kitchen, it is cooling homes with water and a fan, and it is being reinvented in labs as the future of cooling. So the next time you stand in front of an open fridge on a hot day and feel that cool air spill out, remember, making cold felt like magic for most of human history. And someone in the Persian desert figured it out by hand before your freezer was even a dream. That is the everyday equation. I will see you in the next one.